Today we will discuss about the electroencephalogram. The bioelectric potentials are generated by the neural activity of the brain is called as a electroencephalogram. So now this electroencephalogram, how to connect into a human being brain? If for example, so we need to connect electroencephalogram into a human being scalp of the human being brain. So now to interface different electrodes, so one of the electrode connected here, another second electrode, third electrode, and fourth electrode, and fifth electrode, and these are the different electrodes we need to connect into different positions. So now rhythmical potentials are generated by brain. So these potentials originate from the individual neurons of the brain. The waveform pattern complex is termed electroencephalogram. So the millions of the cells discharge synchronously and it will generate different potentials. So from the neural activity of the human being, so brain. So if neural activity of the human being brain, so we need to measure so by using the electroencephalogram. Now to measure awake and alert ECG frequency. If for example, for the measurement of awake and alert frequency. Now what in front panel of the electroencephalogram, awake and alert response. So we will see the waveform output. So this is your awake and alert. Now this is your awake response and alert alert response, and second one is a deep sleep. So if you are going to second one, move into the deep sleep. The deep sleep electroencephalograph frequency. Now so breathing up and down, so breathe out your waveform, it will be seems. So breathe in your waveform again, breathe out your waveform, so breathe in your waveform. So now it is a deep sleep WEG frequency responses. Now other one is electroencephalograph. Second one, the signal of the electroencephalography taken from the different electrodes on the scalp. So we know that we see in the previous one. What are the basic frequencies of electroencephalography? So these are classified into so five types. What are the five types means? In that first one is a delta waveform. So now your first frequency is a delta frequency, and second one is a theta frequency, second one theta frequency, and third one is a alpha frequency, and fourth one is beta frequency, and fifth one is a gamma frequency. So these are the five frequencies, 1 and 2 and 3 and fourth one and fifth one. So these are the different frequencies. So we have a different ranges of these frequencies. So then what are the different? So delta wave, so it will be seems like general range is 0 point, it will be a 0 0.5 hedges to 4 hedges. So 4 hedges. And second one is a second one, this one is a theta wave. If it will be 4 hedges to so 8 hedges now. And alpha wave is a 8 hedges to 13 hedges, and gamma is 22 hedges to 30 hedges. So these are the different frequency ranges. So if we need to measure the human being electroencephalography frequencies by using these uh, five bands of the frequencies, and so doctor is able to understand what kind of diseases and what kind of tumors are present. So why the problem mentality problems are getting from the brain. So we need to observe in the front panel of the human being brain. Now we need to see the different frequency ranges here. So what are the different frequency ranges? In this way, in this case, we have to observe the different waveforms of a human being brain in this one. So first one is a shape of your waveforms. In that shape of the human being brain, we need to see here what is the shape of the first one is a delta wave. First one is a delta wave, the shape of the waveform on the front panel of the CRO. Second one is a theta wave, what is the shape of your front panel of the CRO. And alpha wave, shape of the your CRO. And beta wave, the shape of the CRO screen. now. So we have to be identify here. So different ranges of your frequency ranges, this shape of your waveform, so we need to see the frequency ranges. So why it will be generated from the human being, so brain. So why the frequencies are generated from these different ranges. And that first one is a the frequency 0.5 to 4 hertz. So normally it will be premature of your deep sleeping of the adults as well as the children's. In night time they are talking more and dreams. At the time they are talking and walking something onto the floor. The frequency is 0.5 to 4 hertz. And second one is a theta wave. Now first one is a this one is a delta wave, and second one is a theta wave. This theta wave frequency, this theta wave frequency range, this theta wave frequency range 4 to 8 hertz. The children and adults are sleeping, so then we need to generate the waveform. So we have to be seen the previous one. Now third one is a alpha wave, so that is over 8 to 13 hertz. So normal eye is a closed, then you are generating the frequency alpha wave frequency. And finally last one is a, so that is your alpha wave, and last one is a beta wave frequency. Now this beta wave frequency 13 to 30 hertz, normal eye is open at that time, so we need to generate this beta wave frequency. So finally we need to observe here the frequency ranges as well as the shape and frequency and occurrence, what are the regions of these frequency ranges. So we need to observe these different waveforms. We need to observe these different waveforms. We need to observe these frequencies, electroencephalography frequencies here. So another one is different frequencies. Now here we need to consider so beta wave. So here also another waveform, so we need to generate in the front panel of the. So first one is a beta wave 13 to 30 hertz, the new frequency generated in the front panel of the CRO screen. And second one is a alpha wave, so we need to generate a three different bands of your frequency, first one and second one and third one. And second one is a third one is a theta wave frequency 4 to 8 hertz, children sleeping and adults sleeping, so your output waveform will be seems like that. And delta frequency 0.5 to 4 hertz, infant sleeping and adult sleeping, so your output waveform it will be seems like that. And last one is spikes and epilepsy. Sometimes children as well as adults above the 50 years, they are walking some long distance like 5 kilometers or 4 kilometers. Suddenly they are fall down onto the earth. At the time you need to generate the spikes frequency. So now these are the different five frequencies are generated from the human being scalp as well as diseases. And so now we have to be a spikes and wave of the abnormal shapes occurring during attacks of the epilepsy, the excitation or the damping of electrical activity in the cortex can be due to tumor. Another one, so tumor presses on the neuron as well as destroy them. Oxygen deficiency due to the circulatory disturbance similar to bleeding would be so causes, that is also another important here. And similar problem, earlier damage present in the cortex in the form of a tumor or some may generate abnormal electrical activity. So another important point is electroencephalography here. For examination of epilepsy and brain damages and brain tumors and other organic brain injuries, there is a occasional use of electroencephalography for determination of this level of consciousness. That means like a depth of anesthesia. So it can be also establish the depth of the brain. So this is the major concept of the electroencephalography is very important in nowadays in the hospital section. Now this is your final concept of electroencephalography.